Okay, today we'll start Unit 1 Waves. Okay, I hope all of you have already started your course. If you have not started it, it's fine. Make sure to start it immediately. So in this unit, we'll learn about waves, which include or help describe a wide range of physical phenomena, including earthquake, waves, sound waves, and electromagnetic waves. And today we'll complete the following activities: discussion and introduction to waves. Okay. So before starting our live session, I want to share with you Google document link from where you can access all the video recordings. Okay. Now let me go to the chat and paste it. No, this one is not. Sorry. So give me 1 second. Let me share the Google document link with you all. Okay. Not sorry. Check your message in your chat and open that Google document link, all of you, and make sure to bookmark that link. Okay. I'll upload all the class recordings on that Google document link. Just to make sure, are you able to open that link, all of you? Give me a thumbs up if you are if if you are able to open it, or just type yes. Yes, okay. That's fine. Thank you very much. Okay, now let's start with the discussion, okay? And then please feel free to unmute anytime, or you can ask question through the chat as well. Okay, here is the discussion topic. Who wants to volunteer and read this discussion topic? I'll give you some time to decide. Do anybody want to volunteer and read this discussion topic? Okay, let me read it, okay? So the discussion topic for your Unit 1 waves is select a musical instrument, research the instrument and explain how it works in terms of sound production and resonance. Describe how a musician can vary the pitch and loudness of the notes. Explain why different types of musical instruments sounds different even though they play the same notes. My question for you all is, why this discussion topic has different colors? Why did I color a color it in a like different way? You can type your answer, or you can unmute and answer that question. Yes, each one is a different question. Wow, that's great. Thank you very much. I really appreciate it. So that means you have to, whenever you answer your discussion topic, make sure to split into different parts. Okay, so it has 1 part, 2, 3, 4 different parts, and try to answer it. Yes, and then try to answer it all the parts of the discussion topic. And then you can always Google it. That's fine. But whenever you Google it, make sure to cite your resources, and then always use those websites whenever you Google it. Okay, .edu, .gov, or any library. Okay, .edu, .gov. You can use those websites for your research. And then I think you all are seeing that search engine for education. It will be helpful when you go to your college as well. So I'll share that information with you all as well. Okay. Copy. Here. And then you can bookmark this website. It has different search engine for students. Okay, you can bookmark that website as well. Okay, and then as long as you answer all the parts of the discussion topic, you will always get a full credit. Okay, you will always get a full credit. And I have seen that some of you have already completed discussion topic. That's great. Now let's go to the next slide. If you have any question, please let me know. I'll pause here for some time. Okay, now our first lesson is introduction to waves. The objective of this lesson is to define a wave and distinguish between mechanical and electromagnetic waves, and also will describe transverse and longitudinal mechanical waves. And then in your tutorial, we'll have what is wave, the definition of transverse and longitudinal waves, and electromagnetic and mechanical waves, and at the end, we'll have summary. And then when we complete our lesson, we'll go through some of the questions from the mastery test. Let's start with the definition of wave. A wave is a disturbance that carries energy through matter or space. The wave is a disturbance that carries energy through matter or space. And then we can consider some of the examples of waves. Let us suppose if we consider earthquake. In earthquake, stored energy in Earth's upper mantle is suddenly released, creating vibration on Earth's surface. Similarly, in sound waves from a speaker travel to our ears through air. In that case, air molecules pass the sound waves along until they reach to us. And then if we talk about mechanical waves, such as water waves or sound waves, transfer energy from one point to another point travel through the particles of matter. That means in mechanical waves, energy will transfer through the medium. And this matter in which transfer the wave is called medium. And then we'll go through mechanical and electromagnetic waves in detail later. So this is all about what is wave. Let me do something here again, okay? Give me 1 second, okay? I'll share sound as well. I didn't do that one, share, okay. Okay, now let's go to the next slide. So now let's watch a video that will describe wave motion, different types of waves, and then how the energy will move from one point to another point through the medium. So let me play that video and I just want to make sure that did all of you hear the sound? Give me a thumbs up if you hear that sound. Okay, that's fine. Thank you. Okay, let me play the video.
Energy. Whether it's sea waves, the light waves of a laser beam cutting through steel, waves in the Earth's crust causing earthquakes, or the waves which made the Tacoma Bridge shake itself apart in 1940. To take a closer look at how they behave, waves are best studied in a tank of water. The water appears to be moving from right to left. Pushing a dipper into the tank at one end produces a series of simple waves. The waves move along, but place a float in the water and it stays where it is. So what is moving, and in what direction? To look at waves in more detail, Models have been devised to help explain their motion. Focus on just the orange spot and you'll see that it moves up and down. It oscillates. Although the waves travel from right to left, the particles on the surface of the water are simply bobbing up and down. This movement is at right angles to the direction in which the waves travel, so it's called a transverse wave. These waves are both transverse, but they look different. The difference is the distance from one peak to the next. It's called the wavelength and is measured in meters. The top wave has double the wavelength. Another characteristic of a wave is its frequency, the number of complete waves which pass a particular point every second. Change the frequency and see what happens to the wavelength. How are frequency and wavelength related? You can produce a simple transverse wave by moving a spring from side to side. Another type of wave is given a different name. This time a pulse is sent along the line of the spring. It's called a longitudinal wave. Fix a marker to one part of the spring and you can see that once again there's an oscillation. But this time the motion is backwards and forwards. For both types of wave, energy is transmitted along the spring, but the spring itself doesn't move forwards. Energy is transferred, but matter isn't. Light waves and water waves are both transverse. Sound waves are longitudinal. They're a series of compression waves travelling through the air. Earthquakes are caused by both transverse and longitudinal waves travelling through the ground.
Okay, thank you for watching that video, and then we'll go through some of the contents of that video on our upcoming slide. Okay, now let's start with transverse and longitudinal waves. And then if you have pen and paper, I'll suggest you to write the notes as well. Let's start with the transverse waves. So in a wave in which particle of the medium move in a direction perpendicular to the motion of the wave is called transverse wave. So here we can see that wave is moving in this direction like that, direction of propagation of wave. And then particle is moving up and down. So this is the direction of particle motion, and they are perpendicular to each other. So that kind of wave is called transverse waves. Now some of the examples of transverse waves are light waves, and some seismic waves are transverse waves. Okay, now let's go to the next slide and talk about longitudinal waves. Waves in which particles of the medium move parallel to the wave are called longitudinal waves. That means particles of the medium and then wave, they are parallel to each other. That kind of wave is called longitudinal waves. And then in longitudinal waves, individual particles of the wave medium vibrate back and forth to transfer energy. They will vibrate back and forth like that. Back and forth like that. And a good example of longitudinal wave is sound wave. Sound wave is always the longitudinal wave that travels through the air. And we can see that there will be compression and rarefaction in longitudinal wave. And then wavelength is the distance between two consecutive compression or rarefaction. In that way, we can define wavelength. So let me pause for some time here. If you have any question about transverse wave and longitudinal waves, please ask me that question, or give me a thumbs up if you understood the concept. Okay, thank you. Now let's briefly go through the difference between transverse wave and longitudinal waves, and then I'll strongly suggest you to write that note as well. Okay, there will be some of the questions related to those in your mastery test. Let's start with transverse wave and longitudinal wave. So direction of particle motion. That particle is always perpendicular to the direction of transfer of energy in transverse wave. In longitudinal wave, it will be a parallel to the direction of transfer of energy. And prominent feature, how do you identify your transverse waves and longitudinal waves? Transverse waves as crest and troughs. So let me briefly describe what are crest and troughs. Those are crests, and troughs are those like valley. Those are troughs. Crest and troughs. And the distance between two consecutive crests or consecutive troughs is also wavelength. And in case of longitudinal waves, it will have compression and rarefaction. And you can see that part is compression. This one is a rarefaction. Okay. Example, light waves, an earthquake S wave, only S wave, okay? Earthquake S wave. These are the examples of transverse wave. And longitudinal waves, sound waves, and earthquake P waves are longitudinal waves. I'll give you some times to take note, okay? You can take a note. Now let's go to the next slide. Now in this slide, we'll define difference between mechanical and electromagnetic wave. Mechanical and electromagnetic waves. So let me briefly describe in key terms how can we define mechanical waves and electromagnetic waves. Mechanical waves needs medium to travel. Medium to travel from one point to another point. Electromagnetic waves does not require medium to travel. Just write medium cross, okay? Just for you to remember, medium cross. That means it does not require medium to travel from one point to another point. Now let's go through the definition. Waves that can travel through a vacuum and always require a medium are called mechanical waves. So that means mechanical waves always require medium to travel. Examples are sound waves, ocean waves, earthquakes, vibration of the string. They all are mechanical waves. And mechanical waves can be your both longitudinal and transverse wave. Here only sound waves is longitudinal, all others waves are ocean waves, and earthquakes can be both longitudinal as well as transverse, and vibration of string is transverse waves. Now waves that can travel through a vacuum and does not require a medium are called electromagnetic waves. It does not require a medium. Examples: radio waves, gamma waves, ultraviolet waves are electromagnetic waves. Let me pause here for some time. If you have any question about mechanical and electromagnetic wave, please let me know, and then you can ask your question through chat as well. Okay, if you do not have any question, then let's go to the next slide. Now let's work on some of the problems related to introduction to waves. And those all questions are from your mastery test. At first, I'll give you some time to answer each of those questions based on your understanding. Okay, and then later I'll answer those questions. Okay, read that question and try to answer it through poll, or you can write your answer in chat as well. Question is, which is a transverse wave that requires medium to move? I encourage all of you to participate. Okay. Okay, let me end polling. Thank you for answering. The correct choice is A, that is ocean wave. Okay, ocean wave is transverse wave, and it requires medium to move. Sound wave is longitudinal wave, and both light wave and microwave, they are transverse wave. But they don't require medium to move. So the correct choice is A, ocean wave. Now let's go to the next question. Let me launch poll again. Try your best. The question is, when an alarm clock rings, how will nearby air particles moves in relation to the direction of sound waves? I already got one correct answer, two correct answer actually. That's great. I'm still waiting others to answer. Thank you very much. I already got three correct answer. Okay, thank you very much for answering that question. The correct choice is parallel to the direction of waves. Since when an alarm clock rings, that the wave that is produced is longitudinal waves, and then in longitudinal waves, the particles are parallel to the direction of the waves. And then all of you have answered it correctly. Now I'll give you some time to answer that question. Which statement is true for particles of the medium of an earthquake P wave? Think about the slide that has a difference between transverse wave and longitudinal wave. Okay. And then if you have taken the note, just go through your note, okay? And then you can answer this question. Wow, yep. I already got one correct, two correct answer. That's great. Thank you very much. Now let me end polling. Correct choice is they vibrate in direction parallel to that wave, forming compression and rarefaction. Correct choice is B. So P wave is longitudinal wave, and then S wave is transverse wave. And you can write that information in your notebook. Transverse wave. Transverse wave means the particle and the direction of wave is perpendicular to each other. I'll just make that, okay, perpendicular. This one is parallel. Short notes. Now let's go to the next question. Okay, and then answer this question. I've already launched the poll. The sun generates both mechanical and electromagnetic waves. Which statement about those waves is true? think about the difference between mechanical and electromagnetic waves. That's great. I already got two correct answer. Thank you very much. Okay, let me in polling. Let's do one thing. The correct choice is B. B for beta. The electromagnetic waves reach Earth while the mechanical waves do not. And here is the thing. Okay, let me clarify this question. Mechanical waves needs medium to travel. Medium, I'll write like that. Electromagnetic waves, it does not need medium. So that means only electromagnetic waves can travel from sun to the earth, because in between sun and earth there is vacuum. It does not have any medium. So only electromagnetic waves can travel from sun to earth. And then mechanical wave will just stay in the sun. It cannot travel. I'll pause here for some time. If you have any question on this problem, please let me know, okay? Or you can type your question, or you can unmute and ask me question, or give me a thumbs up if you follow this question. Okay, now let's go to the next question. The question is, which statement about electromagnetic wave is true? I'll again launch the poll. Okay, I encourage all of you to answer this question. Okay. Let me in polling. Thank you very much. The correct choice for this problem is electromagnetic waves don't require a medium to travel. Okay, that is the correct choice. And then this is wrong. And then vibrate the particles of the medium. So electromagnetic waves does not require medium. So C and D is incorrect choices. So the correct choice is B. So we have completed the lesson for today. We still have around 10 minutes left. For rest of the time, I'll put you in a small group or breakout rooms. Two of you in a one breakout room, and then you can talk to each other. It's fine. And then I'll join your room, and then I'll guide you if you have any questions. Okay. Now let me stop sharing, and then let me put you in a breakout room. Let me assign 2 breakout room, and then create a breakout room.